morning. All right, let me answer. Abby said, "Which notes are we doing today?" The sheet that I have up right now, starting with number 11 with circumference and area. That is what we will start with first. I don't know what you're talking about. What is so trippy? But I'll then answer Paige's question, which is the last question. No, you do not need to explain. It just says, in a right triangle, the acute angles have the relationship. What is the value of x? No explanation needed. It does not say explain. So, just find the value of x and just show your work, and you'll be good. And then the third question on the front of the weekly. I went over this one yesterday. So you can see what I have written down so far. I can just explain kind of what I have written down. Let me erase kind of some of the stuff that might be confusing. The most important thing is that you use this idea of 8. They give you the ratio from AD to DB is 3 to 5, but you're comparing an entire triangle. So the best thing to do is use that 8 or 8x. You don't necessarily need to figure out what x is. We kind of did it yesterday without figuring out the 8. But now you have a number to use the entire triangle with. The entire triangle is 8 compared to DB, which is 5. And then you could set up a ratio between AC, which is the big triangle, 9.4 over whatever DE is. Actually, just set up a proportion. That should work just fine. That proportion should give you the correct answer. And then just make sure you round it to the nearest 10. It's almost 11. Let's see. How many people we got so far? 12. We'll wait about another minute or so people can kind of pop in. And Sam is... I don't know what that means. How's everyone doing today? Today should have been the day we would have been back at school, but we're doing this for another 2 weeks at least. Yo también. I forgot what that means in Spanish. Yo no soy. Or yo no sé. If it appears glitchy, try refreshing it, unless it is just glitchy. But just try refreshing the page. Usually that might settle a lot of the issues. Alright, looks like we got some more people now, which is good. We can get started. We're going to start with this page right here, just to look at some of the more challenging ones that we could see with circumference and area. But overall, I don't think it's too challenging. I'd still expect kind of students in 8th grade to be able to do this because this is kind of when you learn it. This has all been kind of a review of that kind of stuff. So we'll just take a look and we'll figure it out and watch some of the there's some loopholes that you kind of want to look out for, and I'm sure we will encounter some of those. So we'll do that. I just want to make sure that I have... Oh. So I make sure I have the calculator ready for you guys. There we go. All right, we'll start with number 11. We'll jump right into it and just kind of figure out what we need to based on the information. Again, we're not going to go through all of these, and you really don't need to write out the whole thing. If you're just kind of writing this out, you can just put C equals 35 and then find R, the radius of a circle. So number 11, they say find the radius of a circle. So I put R equals kind of a question mark to figure out that's what I know I'm looking for. If the circumference, so I'll use C for circumference, is 35 pi. So when we're doing this, we're going to use the circumference formula. We're going to use 2 pi r. You could also use pi times d, but because they want the radius, why not use this one? And we're going to plug in 35 pi equals 2 pi times r. And then all you need to do is divide both sides by 2 pi. And you'll notice this is kind of one of these benefits of working in terms of pi. This is a question I definitely would not be using a calculator for. In fact, if you do use a calculator, you could run into a small problem. We might see that later in the stream. But for now, because we don't really need a calculator for this, because the pi's cancel. So these pi's cancel, which is a great benefit of working in terms of pi. If they just cancel, you just have whatever 35 divided by 2 is, which you probably could do in your head. Or if you can't that, you can throw in a calculator. So you never really need to actually plug in pi into a calculator. And you'd get 17.5. Find the radius of a circle. I'll go to number 13. It says find the diameter of a circle with an area of 615.75 square centimeters. So in this problem, they want the diameter, which is usually it's unusual that they are asking for a diameter when the radius is going to be far more useful. And typically you're going to need to handle this as the last step. The first thing you're going to really need to do, you see the word diameter, it's really find the radius and then double it. Because if you're working with the area of a circle, you don't have a choice with the area. You have to use pi r squared. This formula cannot give you directly the diameter. So you're going to make sure that you use pi r squared. You are finding the radius instead, and then you can, if you know the radius, you can just double it from there. So in this case, we're going to do 615.75 equals pi r squared. And then we're going to solve for r. So first thing you're going to do is to solve for r squared, divide both sides by pi. Now because this is not in terms of pi, we are just going to have to divide it out in our calculator. These pi's cancel out, that's fine. But now we're going to have to break out the calculator and do 615.75. And we're going to divide that by pi. So where's pi? Up here. So we divide that by pi, we hit equals, and we get 195.999. If you're writing out this number, we're not going to round until the very end. So 195. Whoops, I wrote 199. 195.999312417. Actually, what are the directions to even tell us to round to? It actually doesn't. So we'll just round to the nearest tenth like we were doing yesterday. Because almost always they will tell you what to round to. Then from here, this is equal to r squared. So our last step that we're going to need to do is we're just going to square root both sides. So since you have the number already plugged in, you should be able to just hit that square root button. And it should give you an answer. And for me, it's giving me 13.9999, which is going to be, that we can round to the nearest tenth, 14.0. So those are pretty straightforward. The bottom ones are probably the most difficult, so we're going to jump into those. We'll do a couple of these where we'll work with some in terms of pi, which are a little bit easier. Then we'll work with some that are not in terms of pi, and we'll kind of handle those. The reality is, at least when it comes to circles, if you know any piece of information, whether it be area, circumference, radius, diameter, if you know one of those, you can figure out anything you really want. Because these formulas only have really one variable. You only need to know the radius. For 13, we had to find the diameter, not the radius. Oh, very good observation. We had to double that. So I did mention at the beginning of the problem, but even I had forgotten. So you're absolutely right. We do need to double that. Thank you. Can we take the square root of the fraction? Yes. I'm assuming the fraction being 615.75 over pi. Yes, you could do that. You should get the same exact thing. Especially if you don't want to write out that decimal value. That is completely okay. But thank you for that observation. All right, back to 15. Find the area of the circle with a circumference of 26 pi feet. So they're asking for the area, but they've given you the circumference, which is fine. So this is a case, well, since they've mentioned both words, area and circumference, it is likely you're going to be using both equations. Are we supposed to double it before or after rounding? You probably should double it before you round, but because I knew it was 13.9999, you're going to get 28.0 either way. Because they give you the circumference, I'm going to use 2 pi r first. The goal is, if you're given the circumference and you need to go to area, just find the radius of the circle. Even though they're not directly telling you to find the radius, that is really the information you need, because the only piece of information you need to find the area of a circle is its radius. If you know the circumference, you can easily calculate what that radius is supposed to be. So they told me the circumference was 26 pi. We're going to set that equal to 2 pi times r. And then we'll just solve for r by dividing by 2 pi. So again, in terms of pi, makes it really easy. This is one of the benefits of working in terms of pi. They just cancel, so you have 26 over 2. We get the radius of 13. Now that we know the radius is 13, we can go back to the area formula and we can figure out what the area is supposed to be that way. So A equals pi times 13 squared. So we get A is equal to, what's that, 169 pi? Or, rounded to the nearest tenth, 169 times pi, 530 point, I'll round this to the nearest tenth as well, 0.9. And I'm just giving both answers because that's what I was doing yesterday. Typically, directions will tell you to give one or the other, a rounded answer or in terms of pi. I'm still just going to write both. I'd be fine with either answer. They're both the same number, so it really doesn't matter. Now we'll go the other direction with number 16. In number 16, we're going to find the circumference when we are given the area. So it's basically flip-flop. They're going to give me the area information and then go to the circumference instead. So the area, we're still going to use both equations, pi r squared and 2 pi r, except we're going to be using area first instead of second. But same goes as before. You need to find the radius. That's kind of the most important thing with these problems. When you know the radius, you can find out everything. So we're just plugging in. A is 289 pi because that's the area. So that gets substituted in right there. We're going to set that equal to pi r squared. You have pi's on both sides of the equation, which is great. You can divide both sides by pi. Again, same thing. The benefits of having things in terms of pi. They just cancel. So you're left with 289 equals r squared, which 289, I'm not sure if that's even a perfect square or not. So we're just going to check. I'm going to square root 289. It is 17. So that makes it easy. The radius is 17. We can then plug in up to here. So the circumference equals 2 pi times the radius, which is 17. Circumference equals 34 pi for my value in terms of pi, and then we can just 34 times pi, and we get 106.8 for both our answers. Pretty straightforward, I hope. Especially because there's not a ton of new things that we're really doing. They might be multiple steps, but that's probably the only new thing. Instead of doing it, things in one step, we're doing multiple steps to get there. I definitely want to see a few more. So I definitely want to do, we'll do 17, 18, because they're not in terms of pi, and that's really the only difference between 17 and 18. So we will do those. And I'll probably skip 19 and 20, and then we can just move right on to the next section. So in number 17, they're asking me to find the circumference of the circle with an area of 201.06 square inches. We got to find the circumference. Well, since that's what I'm finding, I guess I'll put that over there because I'm going to use that last. And since I know the area, I'm going to use the area formula first. So I'm going to use 201.06 for the area. I'm going to make that substitution in for A. Equals pi r squared. since we are not working in terms of pi, we are going to have to divide this pi out. So we're going to divide both sides by pi, and you're kind of forced to now use the calculator. The pi's don't just cancel out because there is none. So we're forced to use 201.06. We're going to divide that by pi, and then we're going to use this number right here. So 63.9993857.161 equals r squared. Then you could square root both sides. And you get 7.9999. So these problems are most likely trying to give you whole numbers to make it easier. So if we want to just call it 8, I mean, that's fine. But I know in the past I've said we should just write out the whole numbers because they're not final answers. But this number is so close to 8, it's pretty good. I'll just write it out, though. If you want to just write out 8, that's probably fine. Then we're going to plug in here 2 pi times this radius, which is essentially 8. So you can multiply it by 2. Oh, whoops. I think I missed a 9 in here. 616072 times it by 2. So you get 15.999 pi or 16 pi, whichever. That's fine. For your terms of pi. And then we can just round this to nearest tenth, 50.3. I guess both of them are answers. If you were just using 16 pi, I'd be completely okay with that. These problems are kind of designed to try to give you the whole numbers. But whenever you're dealing with pi, because it's irrational, you're never going to get exact values, unless it was in terms of pi. So that's really the only difference between these. The numbers are going to get a little bit longer, and so forth. All right, and the last one that I'd like to do is number 18. And then definitely one thing that I want to make sure I go over with this one. It says find the area of a circle with a circumference of 131.95. And it's not immediately obvious kind of why I'm talking about this one specifically. And there's kind of a little loophole you want to watch out for because it seems pretty standard. We actually just did this in number 15, exactly like this. But because it's not in terms of pi, there's one thing we want to look out for. And I'm going to show us exactly what that is. So since they've given me circumference, which is 2 pi r, we're going to do that one first. We'll do area second. And if I'll plug in my values, my 131.95, then we're going to divide both sides by 2 pi. Divide by 2 pi. And this is where the trouble comes in. If you have a calculator in front of you right now, plug that in and then see what you get. Because there's 2 ways to do this. There's a correct way and an incorrect way. Let me just... I'm going to pull up a different calculator, actually, for this. So I've just pulled up a different calculator just so we could observe the differences between these. So actually, let me see. It was 131.95. 131.95. And then you could divide it by 2. And then I believe there's a pi key somewhere. There it is. So the way I've plugged it in, I can't zoom in unfortunately with this app, but yeah, it came out greater than 131.95, which doesn't make any sense. And if you look at the way I've typed it out right now, this is incorrect. And I can't stress this enough that the way I have it right now typed out is incorrect. Because what it is doing, you need to make it a fraction correct. So yeah, if you're using those blue and white calculators, they will put it in a fraction for you. But if you're using the TI-84s that I gave you, it's going to do something like this. Because if I hit enter, I get 207.267. So if anyone who did it on their own, like I asked, if you just wanted to or whatever, that 207 is actually the incorrect answer. Because look at what happens when I hit enter, and look at now the left-hand side. That's what the calculator is trying to do. It does 131.95, divides by 2, and then multiplies by pi. But you really meant to divide by pi. So the correct way to plug it in a calculator is 131.95. But then when you divide, you want to put 2 pi in parentheses. That way it knows to keep 2 pi in the bottom. So then when you hit enter, you get the correct value of 21.0005. Another way you can do it is if you can start with the 131.95, you can divide by 2, hit enter, and then divide by pi separately. So you can divide by each of them separately. The only thing you want to avoid is the first thing and just throwing a calculator and dividing it by 2 pi, because that is something you can run into getting the incorrect answer. And it's a really good observation that someone made. I think it was Gavin. You notice that he got a bigger value when he plugged in. That should immediately become obvious. How can the radius be bigger than the circumference? It can't be. That's impossible. So that's just one thing that you should look out for when doing these things. All right. So we get the value of r is, what is it, 21 basically? 21.0005. I'm sure there's more to that, but that's just what that calculator rounded to, so that's what I'm going to use. Then we can plug this in, 2 pi r squared. I won't do in terms of pi for this one, I'll just round it to the nearest tenth. So in that case, 21.0005, we're going to square it first, and then multiply by pi. And we get area of 1385.5. So that's kind of the one thing that I wanted to really make sure that I stressed and showed for that. Because that's kind of the only thing that I've seen students make a mistake with consistently. Because it's just the way the calculator works. Your calculator really follows the order of operations, PEMDAS, very strictly. So when you type it in incorrectly, it's just kind of the calculator doesn't understand what you really mean. So that's just kind of what we want to look out for. But I think that does it for the area and circumference part of our notes, which the next page is a homework page. I'm not assigning this. I'm not going to put this in Google Classroom. If you want, you can use it for additional practice, stuff like that. But because you have an assignment already, and I said I'm not going to assign as much as I do in school, we're not going to do this assignment. But again, if you want to, just for practice or for whatever reason, go for it. Be my guest, and I can provide an answer key tomorrow. Just put up the answer key so you guys can check whatever you guys want. But not being assigned, so you don't have to worry about it. Okay? But if there's no questions on area circumference, I am going to jump to the next part of the notes, which I get, I know you guys don't have these printed out yet, so I know some of you are handwriting it, and I'll be mindful of that. So I will go through the notes slowly for anyone who is trying to write everything out. I know some of you were able to print it, which is fine. But again, you don't have to print this stuff. But now we're going to get into angles. And the very first angle we will talk about is one of the easier ones, the central angle. So we're going to take a little bit deeper look into central angles and arc measures. So now we're actually going to be looking at arcs a little bit more closely. And when we're talking about arc measures, we're going to be talking about arc measures first in degrees. So the maximum amount of degrees in a circle we know is 360 degrees. So the circle goes 360 degrees around. We're not measuring the length of them just yet. We will do that later. We probably won't even be doing that today. I'm not even sure if that's in the notes. It is. It's on the next page, but we're not going to get to that until probably tomorrow. So we're just going to be looking at arc measures in degrees. So the very first part, which we have this definition already written down in the beginning of the notes. So I mean, if you want to rewrite it out, go for it. If you feel like you know it, that's fine. But a central angle is an angle with the vertex at the center of the circle. It's the namesake of the whole definition. Central angle comes from center of circle. If it doesn't come from the center, it's not a central angle. And the two sides are radii. So both sides to the angle are radii. Which tells me that whatever their length are, I don't know what it is, that means they're congruent to each other. Because we know all radii of a circle are going to be congruent. And the sum of all central angles of a circle is always going to be equal to 360 degrees. You could make an argument for this circle that there are two central angles, which I know you only see one, but we're going to start looking at angles that are now greater than 360 degrees, which means angle kind of going in this direction right here. We could consider this a central angle as well. It's hard to define it because you can't call it angle ABC. Angle ABC is always going to be either an angle that's less than 180 degrees, but we could start considering this central angle because we could start talking about the arcs that correspond with those angles. So in this case, the example is just angle ABC. ABC is the central angle. And kind of the most important thing about central angles is this concept right here. Is one, if you identify it, you're good. And then the second point, probably the most important thing that goes along with central angles, is the fact that the degree of the arc formed by the endpoint of the central angle is equal to the degree of the central angle. So they are equal to each other. That's pretty easy to utilize, in my opinion. So what does that mean? Go back to the diagram. What it means is we can see that in the diagram that angle ABC is 84 degrees. That also tells me that arc AC out here is also 84 degrees. That's all it means. Remember, arc measures and angles, they're different types of angles, but for circles, this is what it means. So the central angle and that arc measure, exactly the same. So the measure of arc AC is 84 degrees. But then they also ask, well, what is the measure of arc ADC? Well, what's arc ADC? So that's a major arc. So you have to start with A, you have to go all the way around to D, and then end with C. What is the measure of this arc? Well, the whole, part of the circle is 84. We just said that the whole circle is 360. So something very common we're going to be doing is we're going to be using 360 degrees a lot more often than we have in the past. We've used 180 degrees probably like 99% of the time. With circles, it's going to be more common we're going to be using 360 degrees. Unless we're dealing with half a circle. Then we'll still use 180. But for that orange arc, ADC, we just do 360 minus 84, and then whatever we would get right there. So what is that? I think it's 276. Yeah, that's right. 276. So I'll leave that up for anyone still kind of copying things down and looking it over. If you have any questions about central angles, you throw them in now while people are still copying down the notes for those who do not have printers. But central angles, pretty easy concept. It doesn't really get more complicated than this. You can see in the diagrams below, they're just going to give you some basic diagrams. We're going to utilize a lot of rules we already know. Supplementary angles, linear pairs, vertical angles, stuff like that. And we're just going to match up angles and arcs and so forth, identifying them, and we'll be good to go. But overall, not too difficult. All right. Not seeing any questions. I think I've had it up for good enough. If anyone does want to see it, just throw it in chat. Otherwise, you can copy down number 1, pretty simple diagram. And then the stuff on the right you can deal with. I'll just keep it zoomed out. For the last part, you don't have to write, arc JK with blanks and stuff. You can just fill them in when we fill them in, because we just kind of save that for the end anyway. The most important thing is you have the diagram, and then from the diagram, we're going to fill in everything. They gave you one thing. They give you this 21 degrees in number 1, and based on that information, we should be able to find every angle, every arc, and so forth with this diagram. So the very first thing that I want to mark down, number 1, vertical angles. We know vertical angles very well. 21 degrees each. I know it's really small. I'll zoom in just a second though. But if they're 21 degrees and they are central angles, they are coming from the center of the circle, from here to here. So that means those corresponding arcs, JK and ML, are also 21 degrees. Whoops. No problem. So out here are also 21 degrees. So now all I got to do is figure out the arcs next to them as well. So these are also vertical angles, obviously much bigger, but they're linear pairs. We still have this nice straight line being formed right here. So I'm just going to subtract 21 from 180 degrees. I do that, and I get, what is that, 159? Oops, I don't know why it keeps going up like that. There we go. 151. Which means the angle right across from it, the vertical angle, also 151 degrees. And that allows me, well, those are also central angles. Those are bigger central angles. So you can go across 151 degrees, 151 degrees. And then you can double check if you have everything right. All 4 of those arcs, as well as all 4 of those angles, should, since they're the same number, they should all add up to 360 degrees. Isn't it 159? Yeah, it is 159. I don't know why I was thinking 151. My mental math is off today. Yes, it is 150.59. Now we can fill in all the answers. So arc JK. So I like to highlight it, or if you're just kind of doing it, you probably just go over it with your pen or pencil. But arc JK, always assume the minor arc if it's only 2 letters. So that first one I would say is 21 degrees. Angle JNM. Well, that's nothing new. That's easy to identify. JNM. It's this big angle right here. We have it labeled as 159. Then arc KL. So KL, again, is going to be the minor arc because, again, they're only using 2 letters. So I'm going to assume that it is that one right there, not the one in the other direction. So it's always going to be the one that's less than 180 degrees. So that makes this one 159 as well. Then it says arc JKM. Now, 3 letters could be a minor arc. Just make sure that you highlight in this order. So JKM, JK, and then it goes all the way to M. Ignore the L because it doesn't have anything to do with L. It goes all the way to M. So you'll notice, well, I've highlighted 3 arcs that I know, so we just need to add them up. Even though I don't have this number written down, that is fine. 21 plus 159 plus 21. Well, the 21 and 159 is 180, so 180 plus 21 should be 201. So those are really the only ones you got to look out for, are those major arcs, or whatever they give you, because it looks like in the last one, arc MKL, arc M. Now notice where MKL is. It's very easy to go in the wrong direction. I can't go this way because I would hit L. So I'm very mindful of all 3 letters at the same time. I am forced to go clockwise? I'm forced to go clockwise because if I went this way, I've already gone through L. Can't do that. So I have to go this way to MK, and then I need to end at L. So it's the entire circle except that 21 degrees. So you can either just subtract 21 from 360 or add 159 plus 159 plus 21. I think it's easier to think about it like this, but either way will work. So we get an answer of 339. All right. So given that, it's 11:40, so we will end there. I'll stick around for a bit if you guys have any questions about either the assignment before it or weekly, whatever. All right. That's not English, and I don't even know if that's Spanish. I think it is. Have a nice day, Olivia. Who's Billy the Scarf? Something about buying something at a pharmacy? No, I don't know what any of this is. You're welcome, Jess. Have a good one. Thank you, Gavin. Appreciate it. And I will continue drinking my coffee. It's what we do in Spanish. Went to the pharmacy to buy pills for tooth pain. Oh, okay. Fair enough.